Okay, so we have this rational inequality here. We're saying x plus 7 over x minus 4 is greater than or equal to 0. All right, we're going to follow the same procedure, but we're going to have a new understanding for how to identify critical values. See, with a rational expression, critical values include the zeros of the numerator and the zeros of the denominator. The reason the zeros of the denominator have to be included is because the denominator is not allowed to equal 0. So if we take the denominator, x minus 4, and set it equal to 0, and solve, add 4, we get x equals 4. So if we were to plug 4 in for x, we would get 4 plus 7 is 11, and 4 minus 4 is 0. Well, we can't have 0 in the denominator. That's an undefined solution, or a solution that does not exist. Okay? So we can never have 0 in the denominator, so this denominator can never equal 0. That makes this one of the critical values. But we also have to say, what we have to say is that x in this case is not allowed to equal 4. So we cannot include 4 in the interval. So when we make the intervals, we have to make sure 4 is not included in the interval because x is not allowed to equal 4. Okay? But we did identify the 0 of the denominator, and that's one of our critical values. So that's a good start. The other critical values are the zeros of the numerator. So we're going to take x plus 7, set that equal to 0, subtract 7, and x is equal to negative 7. We already knew that, though, because didn't we already say that if we reverse the sign of this, that's our 0? So negative 7 plus 7 equals 0. So we have our two critical values, 4 and negative 7. Now we're going to do what we already did before. We already know how to do. We're going to draw our horizontal line, put infinity, put negative infinity. We're going to put two slash marks, one for negative 7, one for 4, and one for 4. Now let me show you what I do. For the 0 of the denominator, I indicate it on the sign chart by putting a vertical dashed line. And don't worry about why I make it a vertical dashed line, but to some of you it'll probably make sense. Okay? So I'll put this vertical dashed line. That warns me that 4 is not allowed to be a solution. And that's important because I have an or equal to here. So I can't include the or equal to on the 4 because it's not allowed to be a solution. But I am going to go about my normal. I'm going to take a number that's in this region. So negative 7, smaller than negative 7, I'm going to do negative 8. I'm going to put negative 8 in for x here. So I'll do negative 8 plus 7 over negative 8 minus 4. Negative 8 plus 7 is negative 1. Negative 8 minus 4 is negative 12. And a negative divided by a negative is a positive. So I'm going to put a plus here. Now, I'm going to try something that's in between negative 7 and 4. I know 0 is between negative 7 and 4. So I'll put a 0 in here. 0 plus 7 is 7. 0 minus 4 is negative 4. And a positive divided by a negative is a negative. Okay. Now I'm going to select a number on this interval larger than 4. How about 5? So I'll have 5 plus 7 over 5 minus 4. 5 plus 7 is 12. 5 minus 4 is 1. 12 divided by 1 is positive 12. So we have a positive here. And so we're looking for where this thing is greater than or equal to 0. Well, that means positive. So that's this interval, greater than or equal to 0, and this interval, greater than or equal to 0. And so I want this interval included, and I want this interval included. So I'm going to go negative infinity up to negative 7, parenthesis, but it's or equal to, and I am allowed to include negative 7, so I put a bracket. Then I'll put a U for union, capital U for union, and then here I need to go from 4 up to infinity, but I don't want to include 4. So I'm going to put a parenthesis 4, so that doesn't include 4, comma, up to infinity with a parenthesis, and this is my solution to this inequality.